Hello students, today I'll start with IC555 timer. So here in the IC555 timer was introduced by Scientix Corporation in 1970. So this is highly stable device for generating an time delays and oscillations. So the IC555 will be available in 8 pin and also in 14 pin. So here in your syllabus, you will be studying 8-pin IC. As you can see the figure, so you are using 8-pin IC. So 1, 2, 3, 4, 5, 6, 7, 8 pin IC. So the first pin, as you can see, it is a ground. Okay, the mainly we are using in order to generate a delay, okay, or oscillations. So in many of the circuits like in 8051 microcontroller or microprocessor, wherever we need a time delays, they all will be using 555 timer. So once we get to know the pin details of 555 timer, later you will be knowing where all we can use by through the applications of 555 timer. So here the first pin, it is ground, isn't it? So the pin number 1 is ground, pin number 2 is a trigger, pin number 3 it will be output, then it is reset, 4 is reset, 5 will be the control voltage, then threshold, discharge and plus VCC. So let's start with this. The first one is ground pin. Okay, so here is the first the ground pin. Whenever we are connecting any of the circuit, so we have to ground it. So next, triggering. So triggering is nothing but giving input some input. Okay, then third is the output, where you are getting the output, so which are time delays. Then reset, so in order to again set it to 0. So then the control voltage, so this control voltage will be supplied to different parts of the circuit. Then so next is pin number 6, so that is threshold. Why we need this threshold means when we are transferring from positive to negative values or negative to positive values, so depend upon the values. So some values we just by making 0 to 3, if we take it as a positive value, and if it is more than 3, if I take it as negative value, so the threshold is very important, so that we can choose the signal is lies in a positive or in the negative. So that's why we will be getting to know this threshold. Next is a discharge, where we are correcting the capacitor. So by connecting to this, so we'll be knowing the discharging value. So then the plus VCC, so you already know why we need the plus VCC. So it is a DC supply in order to operate the 555 timer. So later we'll be getting to know why this will be called as a 555 timer. Okay, so why will be called as 555 timer? So I'll be telling that later. So here the TTL. So whenever you can see the next, some of the features of I555 timer. So let's see those. So the first feature is it can be the 555 timer can be used to produce accurate and highly stable time delays. I already told it is used to produce time delays, and it has two operating modes, that is monostable and astable. So what is this monostable and astable? So this astable multivibrator is nothing but it will be switching between two unstable states. Okay, there is no proper state, whereas in a monostable, in the case of one stable state will be there and other will be fluctuating. But here this is keep on changing. So it will be positive to negative, negative to positive in the case of a stable multivibrator, whereas in monostable, one stable state and other will be fluctuating. So for your syllabus, you will be studying a stable multivibrator. Okay, so then you can see 555 can operate voltage range from 5 to 18 volts. Okay, so can drive load up to 200 milliamp, as I already mentioned in the circuit. So here you can see it is plus VCC. So we are going to use the range from how much? So we will be using from plus 5 volts to 18 volts. So this plus VCC. So you can use the range of plus 5 to plus 18 volts. So this is the range where you can use. Okay. So the next feature of 555 timer, it is compatible with the TTL and CMOS. So what is this TTL? So the TTL is nothing but transistor logic, and it is CMOS. You already studied, right? It is a complementary metal oxide semiconductor. So you already studied about CMOS in detail in fourth module, isn't it? So why we need this TTL? In order to make it compatible with the motherboard. Whenever you are going to connect any of the circuit, so it has to be compatible. So it is always the 555 timer will be compatible with the TTL, transistor to transistor logic. So then the temperature stability. So it can just maintain the temperature from minus 55 degree to 120 degree C. It can stay. Okay. So it is the range of the 555 timer. So if it is more than this, so IC will be burned and it cannot be used further. Okay. So the next is the applications where we will be using the application of 555 timer. So it can be used as an oscillator. I already told it can be used as an oscillator. Then the ramp generator, the PWM waves and PPM waves, a frequency divider, and the automatic battery charger. So these are the applications of 555 timer. So next, before going to the astable multivibrator, so let's just know about the basic timing circuit. So why we have to study this basic timing circuit means, so in the case of astable, I mentioned there are two modes of operation for 555. So which are those two operation? So one is astable, isn't it? Astable, and another one is monostable. So for your syllabus, you will be going to study a stable multivibrator, isn't it? So in order to go through the astable multivibrator in detail, so first you have to get to know how it will operate, the basic timing circuit. So once you get to know the basic timing circuit, okay, so then it is very easy for you people to understand. So here you can observe the R will be operating manually, means you are giving the 1 or 0 value. Okay, so in the next, the main circuit, you are also using separate op amp for this. So you will be calling it as an LC, that is lower comparator. So here the op amp will be acting as a comparator. You already studied in module 3 that the applications of op amp. So it can be used as an adder, subtractor, integrator, differentiator, and also comparator, isn't it? So here, as it is in lower, so it will be named as lower comparator, and up, this will be upper comparator UC. So this, you, in order to know, if you are getting to know how this one circuit op amp will be acting, so it is very easy to know about how this going to act. So that's why instead of introducing directly, so first let us uh, know about a basic timing circuit. Okay, so here we are operating manually by giving values 1 and 0. So through this operation, if you are learned this properly, it is very easy to know about a stable multivibrator. Okay, so let's see that. So here you can observe in the basic timing circuit. So the range is, you already know, the range of voltage which is used here will be how much? So it will be from the plus 5 volts to, so you will be using 5 to 18 volts, isn't it? So we are that given. So here I'm taking, I'm connecting 15 volts. So then it is connected to an R1 and R. So it is of 5 kilo ohm, and here R2 of 10 kilo ohm, and one transistor is used, and this is which transistor? It is NPN transistor, and this is the capacitor. So which is connected to the collector, isn't it? This is collector, this is emitter, and this will be the base. So then here the R will be operated manually. So either you can give 1 or 0. I will tell why we are giving only 1 or 0. So what is this? So it is the flip-flop. Flip-flop is a bistable circuit where this will be operating in a digital mode. So it is, the flip-flop is a digital circuit. So you already know the digital values only 0 and 1. So you have to work with 0 and 1. So it can have 0 or 1 value for an R. Okay, so this is an SR flip flop. S is nothing but set, and R is nothing but reset. Okay, and it is having your, why it is called bistable means it is having your two outputs. Okay, so this is just a complement of this. Suppose Q equals to 0, so the Q bar, you can observe here, it is an Q bar, it is complement, just a complement 1. If Q is 1, okay, the Q bar will become 0, complemented values. Okay, so let's see this circuit, just a brief introduction about what all this. Okay, so the next is, what is this, uh, wait, so what is this SR flip flop? I'll just write a table of SR flip flop. Okay, so then it is very easy to know. Okay, so the SR flip flop, so S is set, so it will be having 0 0 0 1 1 0 1 1. Okay, so in detail you will be studying this in fifth module. So for, if it is 0 0, the output will be no change, means it will be following the previous state only. If S is 0, R is 1, so the output will be reset. Reset means it will be 0, Q will be 0, Q bar obviously it will become 1. If set is 1, R is 0, this will become set, and this will be 0 because the complement to each other, and 1 1, so it will be intermediate, we will be telling intermediate, and this you will be studying in detail in the next chapter. So just remember these values for the operation, you have to know the operation of 555 timer. So here first let's start with this plus 15 volts. Okay, so here the I already told op amp, so here the op amp is using as a comparator. Okay, the op amp will be used as a comparator here, and this positive indicates the non-inverting terminal, and negative indicates the inverting terminal, and it is the output of the op amp is given to yes, and to the input has shown in the figure, it is given over here, and you can observe this part, whereas this part it is acting as an voltage divider circuit. So then let's see, I'll just brief out about what are this. So here at this point, so the voltage, suppose if I assume the voltage at this point has V1, suppose if I assume the voltage at this point as V1, what is the voltage at this point? So anyhow, the voltage at this point and this point will remain same. Why? There is no resistance. There is no resistance means there will be no drop. So whatever you have voltage, the same voltage will be maintained over here. So the same voltage will be maintained over here. Okay, so first the flip-flop, I already told this flip-flop is a digital circuit. It will taking only digital values. Okay, so but the op-amp, it will be giving an analog output, isn't it? So it will be giving analog. So how you can convert this? Suppose the output of this op-amp is a positive value. Suppose the output of this is a positive value and I am taking it as 1. That's why we need a threshold. Okay, suppose the output is negative, we'll be taking that has 0. So depend upon the output of op-amp, as it is an analog circuit but this is a digital one. So if the output is in positive values, it will be taken as 1. If it is negative value, output of an op-amp is negative, it will be taken as logic 0. So depend upon this. Okay, so first let's we assume this output of an op-amp. Okay, so let's assume the output of an op-amp is 0. Okay, so depend upon, you can assume 1 or 0. So let's take the value of the this output. So I'm taking the q. Okay, so the q has, sorry, s as 1. The output of the op-amp is positive value. Okay, so when this will becomes positive value, when the non-inverting terminal is greater than inverting terminal, isn't it? When the voltage at this point is greater than this point, then only it will be getting the output has the positive value. When the output of an op-amp is positive, so what we assume that if it is positive, it will become 1. Okay, so when s is 1, if I take r has 0, so when s is 1, r has 0, what will be the your output? I already told, when s is 1, r is 0, your q will becomes 1 and q bar becomes 0. So depend upon this, isn't it? This is q and this is q bar. So depend upon these values. So now q becomes how much? 1. So q bar becomes 0. Okay, so where I am taking the output across q bar. Okay, so when q1 becomes 1, so that will be given to the base of the transistor. When the q is 1, that is a positive value. So then what happens? It will be generating the positive value, it will be taking as a plus 5 volts. So when the base of the transistor is having some voltage, it will automatically gets an equivalent current. So you already know the formula, that is ib is equals to, so what is the formula? So it is IC is equals to beta IB. So whenever IB increases, IC also increases. So depend upon that. So whenever the IB is going to increase, it is an base, it is an IB base current. So when the IB increases, what about your collector current? It will also increases. When the collector current increases, the direction of current will be in the towards this. Okay, so the current will be in this direction. So at that time what happens, the capacitors will start discharging. So where it having, so the capacitor will be discharges and all charges will be going to the ground. So when, so let we already assume that v1 and the voltage across capacitor is also v1. Okay, so how it will be? So you can observe v1 minus 0, it is grounded, right? So voltage across capacitor is also 0. Okay, so when this becomes less, where the charge everything, it will, the discharges, the capacitor, everything will be goes to ground, and at that time what happens, the v1 will be decreasing. When the this point is decreasing, what about your non-inverting terminal? It is connected over here, so the non-inverting terminal will be less than the inverting terminal, that this will be dominating, inverting terminal will be dominating. When inverting terminal is dominating, obviously what about your output? So output will becomes 0. Okay, so when the output becomes 0, here the output becomes 0. Why the output? Because the capacitor will start discharging, so whatever current will be, it will be discharging through to the ground. So then this point will be decreases. when the non-inverting is decreasing, or it is less than an inverting terminal, so output becomes negative value. Negative is nothing but what I am taking logic 0. So when it is a logic 0, okay, so if I take the R as 1, so depend upon the table yes R. So if it is 0, R is 1. So what about your Q and Q bar? So this will be 0 and this will be 1. So once depend upon this, so S is 0, R is 1. The output of the flip-flop will be 0. So this is 0, this is 1, and this 0 will be given to the base of the transistor. When the base of the transistor is 0, okay, so what about your current? Current will be, the base current will be 0. So then IC is equal to beta IB, isn't it? So when there is no base current, the collector current also decreases. So when the collector current also decreases, the capacitor, so which is discharging to the ground, it starts charging, because there is no connection, because there is no current, the collector current is not there and it is not dominating. So at that time what happens, the capacitor will be starts charging through this R. Okay, so now the current will start flowing and the capacitor will be start charging through this R. So when it starts charging through this R, so the capacitor will be charged. So here you can observe at this point, so this will be acting as an voltage divider. So if I want to calculate the voltage across this point, it is nothing but here. Okay, so what will be the voltage across this point? So just here, if I take, it has V2. V2 is nothing but I into R2. So why it will be V2? So this point and this point, the resistance, if I assume it has an V2, okay, so V2 minus what is here? If you take, in order to know what is the voltage across R2, so it is grounded. So V2 equals to 0 becomes V2. Hence the voltage, the drop across R2 will be also V2. So, but my intention is to get the voltage at this, because it is acting as an voltage divider rule. So whenever I have to at this point, so you already know the voltage divider formula. So the main voltage, it is nothing but VCC. VCC into where I have to get the drop at this point, I am finding out. So what is the resistance there? So the resistance will be R2. So over the total resistance is R1 and R2. So this will become R1 plus R2. Okay, and this is about a basic timing circuit. So once it is starts increasing, so when it is starts charging, so the again this point will be start increasing. Once the non-inverting terminal is greater than inverting terminal, what happens, again this output of op amp becomes positive value. When output of op amp becomes positive value, again the S will becomes 1. Okay, so if I assume R has 0 now, 1 and 0, the output will be 1. When the output is 1, this will be 0. When this is 1, so again the transistor will be switched on. So then the current will be, base current increases, collector current also increases, and the capacitor will be start discharging, and it will be going to the ground. Again this point becomes less, so it will just continue. So the same equation was given over here. So you can see I already showed how to calculate the voltage or reference voltage or potential divider formed by R1 and R2. So that is what you can observe here. VCC main voltage into R2 by R1 plus R2. If you calculate by substituting value, so you'll be get to know 10 volts. Okay, so this is about the basic timing circuit, and let's see the waveform. So I already told, whenever there's an uh, starting, so there's 0 volts. So when the capacitor starts charging, so you may remember when I told the capacitor starts charging. Okay, so at that point, when the capacitor is charging, your output, when the capacitor is charging, this point, the Q point, will be equals to how much? When this Q is 0, this Q bar is 1, then only your capacitor starts charging. So that's what we showed here. You can observe in the waveform. See, whenever this capacitor starts charging, so then the output will be 1. When only when the output of the flip-flop is on or 1, Q bar is 1, then only your capacitor starts charging. Okay, so this is about the basic timing circuit.